Howdy folks, Mr. Reed here, and welcome to one more question. So for today's question, what I'd like to take a look at are transformations of functions, specifically vertical and horizontal translations, taking them from an algebraic representation and turning them into a word description of what's going on. So we're going to do this at a mild level of difficulty, so in introductory form. So if that's what you're looking for, you're in the right place. Let's get to it. All right, so I have two questions up above. Those two questions are just simply looking for word descriptions of those transformations. So before I get into how to do that, I want to talk about a generalized form of translations that I'm going to kind of compare these two questions to so that we can get a sense of how these would work, not just for those, but in general. So let's state that we have a g of x, and that is equal to f onto x minus h plus k. So g of x is just some general function, and so is f. But g is being described as a transformation of f. And that transformation is going to happen because we have an h value and we have a k value. These two things are parameters, and I'm going to spoil the fun and tell you that one of them controls the horizontal translation of the transformation, and the other one controls the vertical translation. So as you can tell with my examples that are above, one of them basically has a k value and no h, and the other one has an h and no k. So I'm going to start out with the m of x example. So we have m of x is equal to f onto x plus 3. So, great. What we're going to do first of all is match these two things up. And what I mean by that is what we've already written down as being a generalized form and the argument in this particular example, which is x plus 3. So the gut reaction is to say that h is 3. But that's not true because it's x minus h in my generalized form, and it's x plus 3 in my specific example. So what that ends up meaning is actually that in our case, we have an h value of minus 3. And that's because in order to get plus 3 there, we'd have to subtract a minus 3, and that would give us the same thing. So we have an h value of minus 3. So in order to see how this is actually affecting our m of x function, instead of just being equal to the original f of x function, how is it related? Well, I'm going to pick a particular value of x, which is an input value. So I'm going to say, just because it's a nice number, x is equal to 1. So what happens then to this particular expression? Well, that would be m of 1 is equal to f onto, and then it's the 1 that is the x value. So it would be 1 plus 3, which means it's the same thing as f of 4. So what we've done is we've said that f of 1 plus 3, which is f of 4, is the correct value for the position at an x value of 1 on the m function. So if I just bring up a little number line here to kind of get a comparison of what's going on here. So if I say 1, 2, 3, 4, when we put in a 1 for the value, it's like we had put in a 4 on the original function, but that 4's value gets moved back to the 1 because that's what we actually put in. So if we look at the number line, that's a movement of from 4 to 3 to 2 to 1. That's 3 units to the left. And if I put in an x value of 2 instead, then we would get an 2 plus 3 inside of the argument, which would give you f of 5, and that 5 would behave like it had been placed at 2 instead. So again, a movement of 3 units to the left. So an h of negative 3 seems to be a translation of 3 units left. And if we were instead to have an h value of positive 3, then that would be a translation, and everything would be backwards, of 3 units right. And so negative h, left translation, positive h, right translation. Great. That lines up the way we think it should, and we should be happy with that result. The only thing that's a little bit awkward is most of us won't be like, Oh, yeah, of course, the h value. Most of us will look at this x plus 3 and think, oh, it's plus 3. That means moving to the right because it's a plus. But that's not the h value. That's just what's part of the algebraic statement for the argument there. So if we want to actually look at comparing so that we get positives go right and negatives go left, you have to look at the h value, the parameter that's there. If you like to do it the other way, where you just look at the algebraic statement of the argument, then you have to do the opposite of what you see. So for us, it was a plus 3. Plus means move in the negative direction, actually. So as I said, the opposite. Doesn't matter which way you like to see it, just become consistent with how you view it and make sure that it's clicking along with what you expect and things will be good. All right, so our next example is p of x. So p of x is equal to f of x minus 5. So as I said before, last time we had an h and no k. This time we have a k and no h. So let's see what happens in this particular case. So if I were to, first of all, try to figure out what the k value is in this particular case, well, my k value is actually negative 5 because it's just simply plus k at the end. So plus minus 5 is that k value. So that lines up really, really nicely. I'm going to say that we have an x of, I don't know, let's go with 4 this time, just to change it up and put it in a different spot. So if I want to evaluate our new function, which is p, at 4, that would be the same as f at 4 with a minus 5 kicking around afterwards. So the f at 4 means that we actually evaluate the function at the same spot that it used to be. So, you know, if f at 4 was a 10, then it's still a 10. But after we figure out what that function has a value of, we are then subtracting 5 from it. We're adding or subtracting an additional value onto our answer, or the y value of the function. So last time we were modifying the value before it went in, and that affected things horizontally. This time we're modifying the value after the function has been evaluated, and that's going to affect things vertically instead. So in this particular example, we would have minus 5 units from whatever that y value is, which is going to move it down 5 units. So a minus 5 there is a translation of 5 units down. And that's simply it. So for the k value, positive is going to mean up, negative is going to mean down, which corresponds nicely with the h value, negative left, positive right. And as long as you realize that for the k values, it doesn't get mixed up in terms of the sign that is in between the f of x and the k that's at the end, a negative actually is down and a positive is up for this one. So make sure you memorize which way is which and get into a groove of being very comfortable with that. And once you do, it's pretty easy to figure out whether you're looking at a horizontal or a vertical translation and which way those things are going to move. So I hope you found some of that useful. If you did, like, subscribe. If you have any comments on how I can make things better, please feel free to let me know, and I'll see what I can do to fix things up as we go forward. Take care, folks.